Hello students. Now we consider the solution of non-homogeneous differential equations, that is of the form f of d into y equal to x, where x is a function of x. In the previous classes we found some solution when x is 0, and when x is 0 such an equation is called as a homogeneous differential equation. So here we found the auxiliary equation, that is given by f of m equal to 0. We solve that equation, you will get two or more roots. Then in each case we write the solution, and in that case the solution is given by y equal to complementary function, because the right hand side is 0. Otherwise, the solution for such equations is given by complementary function plus a particular integral. So, if it is homogeneous, particular integral is not there, it is just complementary function. But now we are considering the case where right hand side is some function of x. So, the solution of this differential equation is given by complementary function plus particular integral. So, what is the particular integral? Particular integral is given by 1 by f of d into x. So, now we shall find particular integral for different cases of x. So, in the first case, we consider x equal to e power x. So, when x is e power x, particular integral is given by 1 by f of d into e power ax. So, our differential equation is of the type f of d into y equal to e power ax. So, right hand side e power ax, such equations we are considering now. Left hand side it's a function of d, y and its derivatives. So, let us see how to find the particular integral. Now, for this, I will consider the derivatives of e power ax. So, let us consider the first derivative of e power ax, that is, we call it as d by dx of e power ax. So, we know d by dx of e power ax equal to a into e power ax, or we can write it as d of e power ax is equal to a into e power ax, because where d means derivative d by dx. Similarly, find the next derivative d square of e power ax, d by dx square by dx square. Second derivative of this, it is derivative of the derivative. So already a is there, another a into e power ax. So this is a square into e power ax. Or we can write that the second order derivative of e power ax is a square into e power ax. Similarly, if you find d cube by dx cube of e power ax, we get it as a cube into e power ax. This can also be written as d cube of e power ax. So, in general, continue like this, we get nth derivative of e power ax. So, if it is third derivative a cube here, so this will be a power n into e power ax, and this is nothing but nth derivative of e power ax. So these are the derivatives of e power ax, d of e power ax, d square, d cube, etc. So now consider this function f of d into y. How is our f of d into y? So consider f of d, you know the general form of f of d is first term d power n plus some constant p1 into d power n minus 1 into y plus p2 into d power n minus 2 into, this is d power n, this is actually d power n minus 1 plus etc. plus some pn into d power n minus n 0. So it is just y. So into y, this is f of d. So this is our f of d in equal to e power ax is the differential equation. So f of d is this function now. So what is f of d into y? It is this function operated on y. So now our y is, consider we want to find f of d of y, that is we want to find now f of d of e power ax. So consider this f of d of e power ax, that is dn plus p1 dn minus 1 plus etc plus pn of e power ax. But this is nothing but dn of e power ax plus p1 into dn minus 1 e power ax plus p2 into dn minus 2 e power ax plus etc plus the last but one term is pn minus 1 into d, and next term will be p. So d of e power ax plus the last term is just pn, a constant or a function of x, into e power ax. Just now we got the formula. Nth derivative of e power ax is a power n into e power ax. And n minus 1th derivative is similarly a power n minus 1 into e power ax plus n minus 2th derivative is a power n minus 2 e power ax plus etc plus pn minus 1 into d of e power ax means first derivative. It is a e power ax plus the last term as it is pn into e power ax. So now you can see that in all the terms e power ax is common. So what remains? E power n plus p1 into a power n minus 1 plus p2 into a power n minus 2 plus etc plus last term pn. So look at this function. We know this is our f of d. So compare this f of d and this one and this. We can see that in place of d we have a throughout the term. So if this is f of d, this is nothing but f of a. D is replaced by a. F of a into e power ax. So now we got f of d e power ax equal to f of a into e power ax. So I will take f of a this side. So 1 by a f of, that is 1 by f of a e power ax equal to, take this to right side. We have to write it in the beginning, 1 by f of d of a power ax. Here it comes here. So but why, that is you write it in reverse order. 1 by f of d, I will write here. So we got now 1 by f of d into e power ax is equal to 1 by f of a into e power ax. And this is what we call it as the formula for particular integral. Particular integral is given by 1 by f of d into that function capital X. Here x is e power ax. So this is the formula for particular integral in the case of e power ax. But with one condition, that f of a should not be 0. Let us see what is the solution if f of a is 0. So this is the particular integral provided that f of a is not equal to 0. So now if you have a function f of d into y equal to e power ax, then solution is given by complementary function plus particular integral, where complementary function is obtained by the formula y equal to c1 e power m1x plus c2 e power m2x or plus c3 plus e4x e power m3x etc. depending on the roots, where m1, m2 etc. are the roots of the equation, auxiliary equation f of m equal to 0. F of m equal to 0, when you solve it we get the roots. Then particular integral is now given by the formula. Actually it is 1 by f of d into x, which is 1 by f of d into e power x, but we got it same as 1 by f of a into e power ax, provided that f of a not equal to 0. So if f of a is not equal to 0, this is the formula for particular integral. So find both of them separately. Then the solution is given by y is equal to complementary function plus particular integral. Substitute this. For example, we have a solution, we have an equation like this: d square minus 3d plus 2 into y is equal to e power 4x. So when you solve this, this is m square minus 3m plus 2 equal to 0. This is m minus 1 into m minus 2 equal to 0. So m equal to 1 and 2. Therefore, complementary function is c1 e power 1x plus c2 e power 2x. This is the complementary function over. Then particular integral is given by 1 by f of a. F of a means here in the place of a we have 4x. 4. So a is 4 now. So for this problem it is 1 by f of 4 into e power ax, e power 4x. So it is very simple. To find the particular integral, we have to replace d by 4. D ಇದ್ದಲ್ಲಿ ಈ ನಂಬರ್ ಅನ್ನು ಹಾಕಬೇಕು. D equal to 4 because this is f of d. We have to write f of 4 means in place of d we have to write this number. So it is 1 by 4 square minus 3 into 4 plus 2 into e power 4x. So this is now 1 by 6 into e power 4x. So this is particular integral. This is complementary function. So add them, we get the solution as complementary function plus particular integral. So write them, it is this expression plus this expression. So this is the solution. Now let us see what happens if f of a is 0. f of a is 0 andre roots are 1 and 2 here. So ಇವೆರಡು ನಂಬರ್ ಅಲ್ಲೇ ಒಂದು ನಂಬರ್ ಇಲ್ಲಿದ್ರೆ suppose it is 2x. Then what happens? m equal to 2 is a root means when you put d equal to 2 that expression becomes 0. So that expression 0 means f of 2 is 0, is something by 0. So this is not the particular integral, something by 0. So in that case, what you have to do is, so if f of a is 0, next case, if f of a is 0, so first I will take this example only, d square minus 3d plus 2 into y equal to e power 4x. See here, we got m as 1 and 2 and f of 2 is 0 now. So f of 2 is 0 means this we will take it as a now. So d minus 2 is a factor, right? Actually m minus 2 if it is auxiliary equation in m. So this can also be written as d minus 2 into d minus 1. This is our f of d then. So if this expression, so I am considering the case with e power 2x. So if d equal to 2, here the value written is a root of the equation, then d minus 2 is a factor. So f of d can be written as that d minus 2 into something, say I will call it as phi of d. So f of d can be written as d minus, here it is 2, in general it is a. So ಇಲ್ಲಿ ಎಷ್ಟಿದೆಯೋ ಅದು, that is the root. So we can write f of d like this. So in such cases, when you put d equal to a, this expression becomes 0. So for that, the root is given by, there is a formula to find the root. Then particular integral is given by, usually it is given by 1 by f of a into e power ax. But f of a is 0 now. That is why we write phi of a, we put x equal to d equal to a in the remaining function. A d minus a factor ತೆಗೆದಿಟ್ಟು ಉಳಿದ ಫಂಕ್ಷನ್ ಏನಿದೆ ಅದರಲ್ಲಿ ಮಾತ್ರ a substitute ಮಾಡಿ. But in such cases we have to multiply it with by x by 1 factorial or x square by 2 factorial or x cube by 3 factorial or in general x power r by r factorial. So that is why we have to take R, I will tell you. R means number of times this root repeats. So here D equal to 2 is a root of the equation. How many times? Only one time. So it is R equal to 1. ಇದು ಒಂದೇ ಸಲ root ಆದರೆ we take R equal to 1. Suppose D equal to 2 is a repeated root. For example, f of D can be written as D minus 2 whole square into D minus 1. Suppose it is a cubic equation like that. Then the roots are D equal to 2, 2, 1. So in such cases, D repeat 2 times. So we take R equal to 2. Similarly, if it is cube, 2 repeats 3 times. So we take R equal to 3. In the same way, if it repeats R times, we have to multiply it with, after substituting D equal to A in phi of D into e power ax, you have to multiply by a factor x power r by r factorial, where r is the number of times that root repeats. So one sala repeat adre, it is just into x by 1 factorial. And if it repeats 2 times, x square by 2 factorial. If it repeats r times, x power r by r factorial. So this is the formula to find the particular integral. That is, once again I repeat, particular integral is given by 1 by f of d into e power x in general. But if d equal to a is a root of the equation, and if d equal to a repeats 1 times, that is d equal to a, no, it doesn't repeat, it's a root, then particular integral is given by 1 by phi of d, phi of a into e power ax into x power 1 by 1 factorial, that is into x. If d equal to a repeats 2 times, then particular integral is 1 by phi of a into e power ax into x square by 2 factorial. And if it repeats 3 times, here x cube by 3 factorial. If it repeats r times, it is x power r by r factorial. So how to get phi of a? F of dla. D minus a ಒಂದ್ಸಲ root ಆದರೆ you have to write like this, d minus a ಹೊರಗೆ ತೆಗೆದಿಟ್ಟು ಉಳಿದ factor phi of d. ಅದೇ if it repeats 2 times, then what happens? It is d minus a whole square into remaining factor, that is phi of d. Similarly, if it repeats 3 times, then it is d minus a whole cube into remaining factor is taken as phi of d. ಸೊ ಝೀರೋ ಆಗಲಿಕ್ಕೆ ಕಾರಣ ಆಗಿರುವ ಫ್ಯಾಕ್ಟರನ್ನು ಕಂಪ್ಲೀಟ್ ಔಟ್ಸೈಡ್ ತೆಗೆದ ಮೇಲೆ ಉಳಿದ ಟರ್ಮಲ್ಲಿ, ಉಳಿದ ಫ್ಯಾಕ್ಟರಲ್ಲಿ ವೆನ್ ಯು ಪುಟ್ ಡಿ ಈಕ್ವಲ್ ಟು ಎ, ಅದು ಝೀರೋ ಆಗೋದಿಲ್ಲ. ಸೊ ದ್ಯಾಟ್ ಈಸ್ ಟೇಕನ್ ಆಸ್ ಫೈ ಆಫ್ ಡಿ. ಸೊ 1 by phi of a will not be 0. So these are the formula for particular integral in different cases when the right hand side x is equal to e power ax. The problems are very simple in this case. So let us now move on to the problems. First one, solve the differential equation d square plus 5d plus 6 into y equal to e power x. So it is very simple. First you write the auxiliary equation. It is obtained by replacing d by m. M square plus 5m plus 6 equal to 0. I will factorize this. This is m plus 2 into m plus 3 equal to 0. M equal to minus 2 or minus 3. So complementary function is, what is that? C1 into e power m1x minus 2x. Then another constant into e power minus 3x, like that. So no repeat, no root repeats here. So it is like this. Then check this one. This is e power ax. That is e power 1x. e power 1x andre a equal to 1. a equal to 1 ಮತ್ತೆ ಇಲ್ಲಿ m same ಆಗಬಾರ್ದು. Same ಆದರೆ this is a root of the equation. D equal to a is a root. When you substitute that, you will get 0. So, these numbers different adre, then particular integral is very simple. It is the formula 1 by f of a into e power ax. Here it is e power x. And where f of d is the left hand side, f of d is d square plus 5d plus 6. So what is f of a? F of a means here a is 1, 1 plus 5 plus 6. Therefore, you can directly substitute here. You need not write it separately. f of a. ಇಲ್ಲಿ d ಯ place ಅಲ್ಲಿ coefficient ಅನ್ನು ಹಾಕುವಂಥದ್ದು. 1 plus 5 plus 6 into e power x you have to write. So it is e power x by 12. Therefore, the solution is given by y equal to complementary function plus particular integral. So y is c1 e power minus 2x plus c2 e power minus 3x plus e power x divided by 12. So this is the solution. This is about the first problem. Now consider another problem. The second problem similar, that is d square minus 5d plus 6 into y equal to e power 4x. So I won't repeat it. You refer your notes. The third problem, it is different now. D square plus 2d plus 1 into y is equal to 2e power 3x. Now see the function. F of d is d square plus 2d plus 1. And e power ax means e power 3x. So in place of a we have 3. Now this is auxiliary equation is f of m equal to 0, m square plus 2m plus 1 equal to 0. That is m plus 1 whole square is 0. So m equal to minus 1 is a root. We should not stop here. We have to write it 2 times. Minus 1 is a root. So complementary function barivaga, we have to take the constant like this, c1 plus c2x, repeated root ige. The root is repeated now. So we have to take the constant like this, c1 plus c2x into e power mx. Both are same, minus x. Then particular integral is very simple here. Look at this, a equal to 3, m equal to minus 1. They are different. So when you put a equal to 3 here, it will not make the term 0. Therefore, particular integral is 1 by f of a into e power ax. So here it is 1 by f of 3 into e power 4x. So put d equal to 3. So 3 square 9 minus 5 into 3 15. Not this one, sorry, it is this equation. So that is d square 3 square 9 plus 2 into 3 plus 1 into e power ax, which simplifies to 1 by 16 into e power ax. 6 9 plus 6 plus 1 e power ax means it is e power 3x. So that's all. So this is the particular integral and this is a complementary function. So solution is given by y is equal to complementary function plus the particular integral. So add the two functions, that is the solution. So this is for a repeated root repeats in the auxiliary equation. Now we shall see the case when one of the root is same as the root of e power ax. A is same as one of the root of the auxiliary equation. So let us consider the next problem. In next problem, we have to find the constants. So I will take one problem now. The fourth problem, d square minus 3d plus 2 into y equal to e power 3x, and additional condition is given y is 0 when x is 0 and x is log 2. Y becomes 0 in both the cases. X 0 adaglu y 0, x log 2 adaglu y 0. This is at the end to find the constants in the solution. We know if it is a differential equation of degree 2, that is it is the second order, not degree, second order differential equation now. So we will get two constants in the solution. A ಎರಡು constant ನೋಡಲಿಕ್ಕೆ ಎರಡು condition. So we shall see at the end So as usual, we now proceed. We first find the solution. So I will explain this briefly. The auxiliary equation is m square minus 3m plus 2 equal to 0. You will get m minus 2 into m minus 1 is 0. M equal to 1 and 2. So complementary function is c1 e power x plus c2 e power 2x. Then here a is 3. A is 3 different from this. So particular integral is just 1 by f of a into e power a x, that is 1 by f of 3 into e power 3x. D ಇದ್ದಲ್ಲಿ ಇಲ್ಲಿ 3 substitute ಮಾಡಿ. So it is 1 by 9 minus 9 plus 2 into e power 3x, that is e power 3x by 2. Therefore the solution is complementary function plus particular integral. It is c1 e power x plus c2 e power 2x plus e power 3x by 2. And now this is the solution. I will take this as equation 2. Now substitute the given condition. First case, y is 0 when x is 0. So y is 0, x is 0. ಇದರಲ್ಲಿ substitute ಮಾಡಿ we get y equal to c1 into e power 0, 1 plus c2 into e power 0 plus half into e power 0. So this is one equation, equation 3. And then another one is y is 0 when x is log 2. So substitute here. Again y is 0. C1 into x is log 2. C1 into log 2 plus C2 into e power 2 log 2 plus e power 3 log 2 divided by 2. So just simplify this. 0 equal to C1 into e power log x is x. So it is 2 plus C2 into e power. To apply the same rule to this, first you take 2 inside, it becomes 2 square. So it is C2 e power log 4. E power log f of x is f of x. So it is C2 into 4. Similarly, this is half into e power log 2 cube. That is e power log 8. E power log 2 cube. E power log 8 is 8. So this is 0 equal to 2c plus 4c2 plus 4. So now look at the equations 3 and 4. So 3 and 4 if you solve you will get the solution. So this is 2c1. You can divide this by 2. So this equation becomes c1 plus 2c2 plus 2 equal to 0. Divide this equation throughout by 2. And equation 3 is here. Write it here. C1 plus C2 plus half equal to 0. This is our equation 3. So just subtract them. We get C2. C1 cancel. C2 plus 2 minus half. That is 3 and half equal to 0. So we get C2 equal to minus 3 by 2. Substitute for C2 in any one equation. So we will get C1 minus 3 by 2 plus half is equal to 0. This is C1 minus 3 plus 1. Minus 2 by 2 minus 1 is 0. So C1 equal to 1. So finally in the solution you substitute the values. We got C1 equal to 1. So the solution becomes now this is 1 and C2 we got it as minus 3 by 2. So this formula becomes minus 3 by 2. So this will be the solution. So it is to find the constants in the solution, these additional conditions, that is e power x plus minus 3 by 2. C1 is 1, right? C1 is 1 into e power x plus 3c2 e power 2x minus 3 by 2 e power 2x plus half into this. So make corrections if any in your notes. If it is written in some other way, C2 is minus 3 by 2, there it is written as 3 by 2. So make the correction. Then we shall consider the problem under repeated root in the next class. So it is enough now. Thank you.